or here. This is the application I was showing in the demo before, if you were here. It's Tiffany 3, currently running on a Pentium Pro on Rhapsody Intel yellow box. This application features, it's a very, very sophisticated image processor. It features multiple layers. You see the butterfly going on and off, or the lady going on and off. You can do such things like normal airbrush paint. You can do such less normal things like airbrush undo and similar things. It's pretty basic. I don't want to demo the application here because somehow I was, well, supposed to be here earlier. And you have text selections, and you can move them around, make them bigger. Marquee here. Oh, we have the font panel for that, actually, to show the cross-platform thing. Here it is, and now I will just go and apply a smoothed out some kind of color panel here, red, select all, zoom in. You see it's kind of smooth into the background, and again you could just go take a pencil and undo it with an airbrush. So thanks. This application also runs, of course, on Mach 4.2 because that's what I'm running on my Intel at home. And you see that here the menu is actually very different from what you've seen in the previous simple demo, which was like there was still the quit and hide menu item out here. And that's because this one uses the, as he said, tweaked nib. This one has been actually tailored to look and feel like a real Macintosh thing. And that goes as far that you can just go and add layers to it on the fly. We have here the butterfly. Let's add another one. Just place it here, and or little Mickey. And so this drag and drop all works. You can save that as one document together with the layers, with the undo buffers, with whatever. And that would also go through the Save As panel. It asks you whether TIFF, document, whatever. So this is how it looks like here. Now, I'm going to show it to you also on the PowerPC. That's something we haven't seen before, as like a true cross-platform thing. Here we have the same application. We also have text selections.
What machine do we need up there?
This is number 5.
Number 5 up, please. Thanks.
Yeah. Number 5. This is a PowerPC. And again, we have a text selection here. Or we used to. This was not rehearsed. I was told yesterday, or the day before, to do this, and I never tested it on the PowerPC here. We rehearsed till about 11 or midnight yesterday, so I missed Star Trek, which made me really angry.
I have it on tape, okay?
Oh, really? Oh, that's good.
Okay.
Okay, so no text selection here, but it will brush with different colors, and you will see here, if the same color wheel, we should have the nifty controls, like say here in Antique. We should be able to double-click the inspector. We will get draggable colors. You go and drag a color into the inspector, and it's going to change the colors appropriately. And so it's the same look and feel, but you get those kind of light gray windows with this pretty slider, Mac style. And how did we port it to this platform? Well, cross-compile. You just go in Project Builder. I don't have a Mac. We didn't have a Mac at the office. We just had normal yellow box, and you select cross-compile to PowerPC. It ran. And then yesterday, Jordan told me that, well, PowerPC is cool, but he also wants people to really believe that it runs on a really, say, very famous and popular, yet maybe not the greatest platform. And so after...
Definitely not the greatest, Stan.
And so yesterday after this infamous rehearsal, I drove home and compiled Tiffany rather quick on NT, which I usually don't do because it's just not the environment to work in.
That's amazing.
And
this stuff really works.
it's been about 2-3 weeks since I was in NT the last time, so it's not really thoroughly tested. So if it dies, please remember this is a live demo. Here we should have some images. We have here Our Lady. Here she is. You can go and apply, say, contrast to her. Now she's much more contrasty than she was before. Undo, redo. We should have, let's do it again, and then let's make her color maps. Make it false color. Imagine she were a satellite image, and, well, okay, she's not. Give me another shot.
Hey,
Give me
it's
another.
Windows.
Give me another shot. Remember, you can often blame Windows for mishaps, that's the advantage of it. And, okay, let's try again. Temp, images. I'm not going to do the false color again. More contrast. No, that was bad. I can do twice contrast, can I? You will forgive me. And you will see the inspector works as usual, although here you have the different kind of icon for the pop-up than it was on the Macintosh or than it was on Yellow. You will get the undo browser. You can go different steps back and forward, as many as you want. It shows you the size of the undos. Everything works as usual. Image navigator, you can zoom in, and the navigator updates live, and you can drag around. So the look and feel is exactly the same, and you should be even theoretically able to drag and drop images into as layers.
Wow. So as you can see, Stan, with very little time, gave us NT, which I think is a testimony to the power of this platform to deliver real-world apps cross-platform. Big round of applause for Stan. And is there anybody who can help him on his pipeline simulation for this EE class? If there's anybody in the audience, see Stan afterwards. Thank you, Stan. Would the Q&A panel come up, please? Mr. Butler, Vitas, Stan? Here, we're going to do some Q&A here real quick. Again, if you want to go to other sessions, we're in the passing period right now. Go. But Lori's being very wonderful to us. A round of applause for Lori, our tech crew, and the rest of the tech crew. Thank you. We're going to do some Q&A here. Okay, we're going to go with this microphone here.
It's working. I guess people from Next, is there any plans on dealing with files that are file wrappers, which on operating systems don't support it, will make what should be a single document appear as a folder with a bunch of stuff inside it?
That's you, Frederick. I guess I'm the only one who can answer. Yeah, we'll be working on that in the future. Yeah.
Oh, okay.
Yeah. Center mic here.
Yeah, I was wondering, does the Rhapsody version for the PowerPC run on PowerPC machines that have new buses on them?
The blue box is very simply just another flavor of Macintosh. That's how it's being done. It looks like just like a Macintosh. And the expectation is, of course, we don't have it yet, yellow box for Mac OS, but it should run in the blue box. Now, of course, that's going to be an interesting,
No, that's really not my question. The question was whether the yellow box will run on top of Power PCs that are new bus based.
That's in terms of the yellow box. You're talking about Rhapsody there.
Yeah, I'm talking about Rhapsody.
Apple has announced that our current plan is to support all machines that we're shipping on January 6th. Which
will
is
it run with a mock kernel?
What?
Will it run with a mock kernel on that?
What?
Will the version that runs on the mock kernel run on a new bus?
That's the question I'm answering. Apple has announced that Rhapsody, which is Rhapsody for PowerPC, which is the mock kernel plus the yellow box, will run on all of our machines that we're shipping on January 6, 1997, which basically is the PCI machines and above.
So it's basically the PCI, it's not the new bus machines.
Current plan is that we have not announced any intention for the new bus machines. We're supporting the PCI.
When do you think you could contrast the customer experience on the version of Yellow Box that runs on top of Mac OS as opposed to the one that will be running on top of?
It'll build a Mac OS application. It's a Mac OS application.
No threads.
What?
No threads, so it really won't be able to walk and chew gum at the same time.
The Yellow Box has all the limitations of the underlying OS that it is running on.
Yeah. Okay, thanks.
Over here.
James Harker at Claris. Thanks for all the great information this week.
Thank you for coming and trusting us once more.
You talked about your OLE support, and I wanted to get a clarification on that. You talked about, actually in MFC, if you compile with an MFC application, you automatically get OLE container support. And I just wanted to know, to what level do you have that automatically when you use the app kit?
Yeah, okay, we don't have OLE container support in the app kit today.
Are you expecting to by Unified or probably not?
I don't think we have any current plan to do that, actually.
Okay, thanks.
This mic here.
I'm wondering about specific timelines because when you talk about Rhapsody, you imply Rhapsody for PowerPC, and I was wondering if there are different timelines for Rhapsody for Intel, or more importantly, Yellow Box for Win95.
You did the timelines.
The current timeline goes as follows. Rhapsody for the developer release, which will ship with PowerPC, simultaneously will ship Yellow Box for NT at that point. And it is planned to do that again at the Premiere release, to have simultaneous shipments, and that's the goal that we have. So summertime for Rhapsody, PowerPC, Rhapsody Intel, and Yellow Box on Windows.
Windows NT.
Windows NT. And that also supports 95. And then again at the Premiere release. Mac OS.
Mac OS, let me just take that one, Dave. Mac OS we just finished the investigation and made the call on it literally weeks before this conference. And they are still building an engineering schedule. And until we have an engineering schedule, we can't give you a ship date. That's the problem. They determined that it was feasible, and now they're taking all that information and using that to build an engineering schedule. We're sharing the information with you as soon as we have it, which means that it's not going to be as complete as we all would like. Center mic.
Could you speak briefly about how far down the Yellow Box will be going to wrap fairly hardware and system-specific services such as serial ports and time services?
Well, the Foundation Kit gives you some of those things, and there will be abstractions for some of those things. I don't think any of us here have that right now, so we can't give you the details. I would suggest that you get those questions and send them to Rhapsody Dev Feedback at apple.com, and we will forward them on to the right people and roll the answers up into the FAQ.
Thank you.
Neil Rhodes, I think it is?
Yes. I certainly appreciate hearing that there'll be no license fee for shipping on Windows 95, Windows NT, Yellow Box. That's great news, and that certainly does reduce risk. Do we have to wait until Golden Master, sometime next year before we can do that? It would certainly reduce risk even more if I could take home what I'm working on now, develop applications, and at least deploy them on Windows 95, Windows NT.
And we'd love to see you do that, actually, even with the current pricing. But the bottom line is we will be trying to address pricing before the unified release. And the goal is to make this as easy as possible so that by Premiere, you're developing and deploying applications. So we fully expect, hopefully around the developer release time frame, to make sure that you feel totally comfortable with that. So, we don't plan to change anything as far as the free runtimes at all. and work out the rest of that pricing over in the short term. So just stay tuned on that, and feel comfortable that that's the game plan. The developer release is not that far away.
Thank you.
Unfortunately, we can take one more question. I really apologize. The people will be up here. So we take this question, and then we'll close it off.
I think I'm still a little confused with the printing with the yellow box. If somebody develops this cross-platform application and decides to run it on NT, are they going to have to install some printer driver for the yellow box on NT, or is it going to use the Windows print system?
It uses the underlying Windows print system. That's the real beauty. In fact, you'll find that that if you're installing the OpenStep for NT, which you have as part of the package, it's actually easier to install on Intel hardware because you have Windows NT there than it is to install on bare NT hardware using the mock. But you get a better and closer to the Rhapsody experience with the mock stuff. So I suggest that you do that, and we'll have a recipe for a machine that you can build that will do that.
So those Windows printers that aren't PostScript, it'll work fine because it's going through the Windows print system, or do they have to be Windows PostScript
Identify
printers?
yourself and tell me.
I'm Greg Anderson. I'm a 6-year Next developer, and we have a word processor and a page layout package, so you can imagine this is important to us. I have already ported that to NT, and I haven't had to worry about printer issues whatsoever.
Great.
In actually using that final distribution. I can tell you it also works on 95. I'm going to rescue Vitas here. I have the most plain vanilla compact Presario you could imagine running 95 at home, and the app runs fine on it.
And you don't have a PostScript printer, it's just a standard
It's like this little $100 inkjet printer.
You need to realize that the printer that Next built and shipped, the laser printer they built, it didn't have PostScript in it. It used the PostScript that was in the system, the display PostScript.
Yeah, I can tell you for certain the machines I'm running on NT and 95 would never have been supported by the mock Intel release, but it's just using all the native drivers that 95 and Intel installed to run on those machines.
Great.
I want to just make a couple of closing comments. Anytime you're putting a session together like this, there's a lot of people that make it possible, and there's a lot of people who make a conference like this possible. I want to thank the whole crew here, both our Q&A panel, particularly Vitas here, who really went out after putting together a sales conference for all the Apple people to brief them on this stuff the last week. He then volunteered to do this. Round of applause for Vitas. Our Next developers who made this technology as good as it is now in terms of pushing the development teams at Next. Dave Butler, a gentleman here in the center, he is responsible for the moniker Yellow Box. And the tech crew that made this possible, thank you. Have a good year. Let's go out and kick some butt.
Modify. Well, the blue box works the same way. If you want your bits to show up in the window in your game, it can work just fine. You just have to remember to call shield cursor show cursor on the area of the screen that you affected so that we know that that's a region of the screen that was dirty and needs to be updated. You're also going to have the ability to toggle between full screen and macOS in a window mode without doing any restarting on the fly. And we have that running in the lab downstairs if you want to play with that. The way that works is by tearing down, using the display manager, all the video displays for all the multiple monitors and then putting up just a new one, which again means that what you don't want to be doing is capturing any base addresses and then using them later, because it's not going to work. That base address might just go away. So the runtime. So as I said, we don't require a hardware ROM. We have our own ROM that we build that's part of the blue box, just like any other hardware platform. Also means that we can update it without requiring a new machine. And that comes with the blue box. We support a 68K emulator, both interpretive and the dynamic recompilation emulator that shipped with the latest Power Macs. And we have this blue abstraction layer that completely insulates blue from yellow. So the blue abstraction layer is the only way that we can communicate between the blue box and the core OS. And the core OS actually can't communicate with blue. It's all done via interrupts, just like the real blue box is, just like the real Macintosh is. So there is no like calling into the blue box, because that would involve trying to run an emulator when there isn't an emulator necessarily running. So the only way to do this is with an interrupt. So we have these simulated interrupts. Just like on a real machine, we have an interrupt tree, and we can create and delete interrupt sources on demand, and that's how we implement our sound and our video, and that's how we get our high performance. It's just like a real Macintosh, except it's sitting one layer up on top of an operating system. So we have this new virtual memory underneath us, and we are going to take full advantage of that. But to you, virtual memory is going to appear disabled. So if you look at Gestalt, you're not going to see VM is on. So what we're going to be doing for performance reasons is providing a new API for requesting held memory just for real-time performance. Unlike today in System 7, where your entire system heap and area in high memory is all held and locked into real memory, the entire blue box is completely pageable, which yields significant memory improvements in terms of how much is actually used. But we understand that for things like QuickTime movies and sound, you don't want to be paging. That causes hiccuping, stuttering, other bad things. So what we're going to be doing is providing this API, and it's a request. And this will allow us to determine if we've got the extra memory to burn, to go ahead and lock that stuff in so that it doesn't page out. We're also going to provide an option for our high-end customers to lock down the entire blue box. Again, for performance and real-time reasons, because you don't want to be taking those hiccups that can critically impact things like printing to tape and other high-end features. So we have this new memory map. This is an option. You can turn it on or off. And it looks like a really large virtual space. Currently, it's 1 gigabyte large. And this allows you to run all of these applications. So instead of allocating the application heap out of temporary memory, we're allocating that application heap out of virtual space. It just comes out of the ether, you don't know where. And it sits above the temporary memory partition and below buff pointer. And we do that so that we get high compatibility, because a lot of your applications like to do address checking. So some of the things that you shouldn't be doing are walking the heaps, because if you walk between the heaps, there may not be anything between the heaps. That would be bad. So then there's also going to be this option for guard pages surrounding the application stacks and heaps. This is a great debugging tool, so that you can detect when your application that you've written is straying beyond the bounds of reality. But this is going to be slightly less compatible. We've already found a couple of applications that do this but work today just because of the side effect. So we will be allowing you to turn this option on or off, perhaps even on a per application basis. We'll see. So this is what that memory map is going to look like. The current memory map, where application heaps are in temp mem and everything is contiguous from 0 all the way up to memtop. And then the new memory map, where you've got low mem, system heap, and temp mem all joined together to present the same image to the system for compatibility, but then the application heaps are just allocated out in space, and then buff pointer and memtop up at the top. File system. So we're going to be supporting HFS, HFS Plus, and a whole bunch of other file system volume formats. We're providing our own custom disk driver that supports 3 different modes. The 3 different modes are, the first one is we've got the disk partition as a blue box only volume. Okay, so this allows us to basically just plug in a disk and show up in blue. Now, if that disk is also showing up in yellow, blue isn't going to see it. Only one person can access these drives directly at a time. If yellow owns the disk, then we have to go shared. We'll talk about that in a second. But this is extremely compatible, and it uses the existing partitions just as they are. And that's, in fact, how we're running the compatibility lab downstairs, is with these first 2 modes, the disk partition and this yellow box visible file. So the yellow box visible file is where we can basically take an image, like an Apple disk copy image, and treat that as the volume that blue sees. It's very convenient. Disk images have always been convenient. It would be nice if we could just mount those, and we will. It's also going to be very compatible. Again, you're using the Macintosh or the macOS file manager unmodified, so there's no compatibility issues or constraints. But the third mode is the most interesting. This is a trade-off that we're making in order to provide an integration level that's superior, so better user experience, but we're sacrificing compatibility for it. And this is likely to be the default mode because it's the more natural, understood mode. So sharing volumes, any volume that's mounted in yellow, can be made visible to blue as an HFS or HFS Plus volume. And you won't know You'll be able to tell the difference from within Blue, but applications that are currently written won't know the difference. It'll just look like an HFS volume or an Apple Share volume, depending upon if it's like a network connection. So it's going to be less compatible, much better interoperability. But again, any software that patches the file system expecting to see everything that the file system, everything that goes through the file system in Blue isn't going to see all those yellow accesses. So those patches aren't going to work. So if you think that you can intercept every I/O to a device, that's not going to work for this mode. And you can mix and match multiple volumes with different modes simultaneously. So you can have many different volumes mounted with all the different modes, and it's just extremely flexible. Devices. This is the hardest part about the Blue Box, because the devices are what are touching hardware. So no native device drivers. Those NVRVs, those DRVRs, drivers in general tend to touch hardware. We're not going to even be providing the native device driver model because there's no point. You can't access the hardware. So that means no name registry, no NVRVs loading. There will be some support for native drivers in the Core OS, though. I think specifically video drivers are going to be supported. We will be providing a model to communicate to the Core OS drivers from within Blue, though. So drivers that show up in yellow, so if you write a new, or in the Core OS, a new Core OS driver will be made visible in the unit table with our own DRVR shim so that you can have applications communicate to a Core OS device. And that will all be provided for you automatically with, from the Blue Box. And if we can't make that work, then we will be providing an API to allow you to write your own shims to communicate with those Core OS drivers. So you will be able to get at your devices from within the Blue Box. But DRVRs that don't touch hardware will work just fine. So things like desk accessories or disk image drivers. So the SCSI Manager. We're going to support SCSI Manager 4.3 and old SCSI, but it's only going to work on devices that aren't currently in use. So just like I said earlier, if a device is currently in use by yellow, we can't get at it. Only one person at a time. So, but we will be supporting the SCSI Manager. So things like scanners that are accessed via Photoshop plugins, those should all just work. Serial ports will be available through OpenTransport and through the serial driver. We have an implementation of serial DMA that imitates a serial DMA access through to the Core OS. But the SCC access directly isn't going to work correctly. Now, we can make that work because we have a virtualized SCC chip that isn't the real SCC chip, but we sit on top of the real Core OS driver. But the performance isn't going to be very good. And things like the MIDI manager, which directly touches the SCC, it isn't going to work acceptably. We can make it work so it doesn't crash the machine, but you probably won't be happy with the performance. No VIA access, same thing. ADB support, any devices not currently in use by the yellow box. Do you get this? It's kind of like a theme. If it's in use in yellow, we can't use it in blue, but we can share it. If it's not in use in yellow, we can use it in blue. So networking. This is probably the most controversial issue with the Blue Box. Full open transport compatibility. It's going to all be there. And that includes the classic AppleTalk services that route into open transport. It's highly compatible, but it requires new low-level drivers, just like any other Mac OS-based computer. So what we're going to do is we're going to take the lowest level of the Core OS and allow Blue direct access to that and share that. Okay? So both AppleTalk and TCP/IP will be supported. Provides printing and Apple Share support. In fact, in the labs, we currently have PPP and ARA working in the Blue Box over the serial line. Works great. So IP addresses are the most interesting issue here because if you completely have two separate protocol stacks, one inside of Blue and one inside of the Core OS, that implies that you have two different IP addresses, which is probably less than desirable if you're a network administrator who has to parcel out these IP addresses. So we're going to be supporting a shared IP address mode. And the restriction there is that we'll be arbitrating the port numbers for IP, which means that you can't run like a file share or a web server inside of Blue and a web server inside of yellow, or an FTP site inside of Blue and an FTP site inside of yellow at the same time, because they both use well-known distinguished port numbers that we can't change for historical reasons. So that's the limitation. But the way this is all going to work is by multiplexing the packets down at the lowest driver level to both the Blue Box and the Core OS. And while this may seem like it's not going to be acceptable performance, it actually will be because that bottom level multiplexing is only going to route the packet to the appropriate place. So we won't be taking any extra interrupts for doing the service. Now, if you're running two intense web servers on the same machine, and one in blue, one in yellow at the same time, yeah, your load's going to be higher, but no more so than it would be if you were trying to do that on top of blue, or on top of real Mac OS. So again, I'd like to bring out Mr. Jim Murphy, who's going to show us some more Blue Box demonstrations. Hello. Hey.
So what we have here is a Power Macintosh 8500 180. It's identical to what we were running the Mac operating system version of the Blue Box. And as you can see, it says, well, it would say Power Macintosh. I guess we don't do that anymore. So I want to prove to you that this is indeed running real macOS on real hardware. I'm going to go into my friend MaxBug, and notice I did this intentionally. Most of the time when I'm here, I see MaxBug through bad reasons, and the person who's demoing it usually feels pretty bad about it. This is intentional. I'm going to use command. If you look at the third line, it says PowerMac 8500. MaxBug believes it's that machine, and that's because it is. So what we're going to do now is boot into the Blue Box running on the Copeland former microkernel for the operating system formerly known as Copeland, called new kernel. And hopefully this will come back up here. And this is, as I said, new kernel starting up. We initially did our Blue Box development on new kernel. We've been working on it for a number of months, as Jeff said, about 4 months. And it's a bit further along than the mock version. For obvious reasons, we've only had about 3 weeks on that. But this is a good demonstration of what it'll be like when it gets in your hands. As we've been saying, it just works. And the proof is on the wall down in our lab. We've got a big, long list of applications that just work. And if you've got yours here, take it on down there, and it should just work. If not, we'll make it work. So that's the plan. So it's booting here again. This is macOS AB3C1. We're now here in the Finder. Almost. And I'll go into MaxBug again. Show you that it says machine is 1206 and doesn't know the name, and that's because it's a new box. It's the Blue Box. And believe me, this is really the Blue Box. It says Blue Box Enabler now, so we're really running on it. It's pretty funny. Down in the lab, there are a number of folks that come in and start to set up their software and then think they're running on the real hardware and didn't realize they're actually running on the Blue Box. There are only a few subtle things that let you know that there's a difference between them at this moment. Anyway. Let's see here. I'm going to run a few applications to get started here. I think we'll start out with a little application here called Adobe Photoshop. This was actually one of the first apps that just started running. We're quite pleased that...
It's really tough for us, For us to show you a cool technology demo is basically just showing you Mac OS, which is really difficult because it's just Mac OS.
So if you're a Photoshop user, here it is. Just works great. I'm not a Photoshop user, so I won't actually do anything with it other than show a demo. Nice little photo here. But it works great. And all of the demos today are being run with sparse memory, the configuration Jeff described turned on. You can't really tell here other than the fact that it says virtual memory is on.
But you'll notice that largest unused block is missing.
Yes.
Because it's completely irrelevant. There is no largest unused block. You want to launch an app, go ahead and try it. If there's enough disk space, it'll work.
So there's one other difference here from the previous demo I showed you. We're booting from a disk image, again, exactly the same image, in fact, and the same ROM and same enabler. We've also got two other volumes here. These are actual partitions on the disk that's inside this machine. They're not being used by the Core OS, so we, as the Blue Box, own them now, and they're completely accessible as block devices, and I'm running the stuff off of it. So let's see, we did a productivity app. Let's play with a game. You notice we actually have sound. We've got everything just works. It's our catchphrase.
Yeah, this is a theme.
Yeah, surprisingly, the things that don't work typically are in our implementation. The macOS just is amazingly resilient when it comes to missing pieces of hardware and things like that. But I'm not the person who should be showing you a marathon game. I'm a really poor player, so I think I'll just go get myself killed up here. But looks great. See, we've also got, we can switch resolutions in the blue box right now since we're running in full screen mode, and we're in 8-bit mode, and I'm going to switch to millions for a little movie playing. Now, you've probably seen this movie. That's probably a good thing because you'll know what to expect.
The unexplained phenomenon is heading for Moscow.
When you've got just 28 minutes to save the entire planet, the clock is ticking. You better hope you got the right computer.
So what you see there is an unmodified QuickTime 2.5 just playing a normal movie with sound. And what would you like to see? We went from productivity to game. How about development environment? Now, we don't have the entire Blue Box source set up here, so we can't do what Greg Galanos did a few years ago and rebuild the entire environment from scratch while he talks. But again, things just work. So
didn't we do something with MPW building Blue on top of?
Yeah, actually, I did one of the demos myself, just to prove that things work. I built the entire Blue Box ROM and system running on the Blue Box itself, and then booted from it, and it worked well. So just I'm not doing day-to-day development work on it, but it just does what it's supposed to do. As Jeff said, it's really hard to say how exciting this is to see it work when the Mac OS we all know and love. As Jeff mentioned before, we also do restart of the Blue Box. We don't reboot the physical machine. We're just restarting the environment that the Blue Box is in. So I think I'd show you that. This is just going to restart the server that is the Blue. And we're to the Happy Mac pretty quickly. And didn't point out, but you notice all the extensions loading. All of yours hopefully will work.
So what you didn't see there was here is a ding and memory test and booting up the Core OS and mounting the other file system.
Because it didn't shut down. We just restarted what was on top, which is the Blue Box. Jeff mentioned we're also, as we're doing full screen here, we also do, or will do, the actual product, macOS in a window. And we have a feature built into it right now for testing the environment that, oops.
Millions of colors mode.
Yeah, indeed. Oops. Faux pas. That would be time to restart.
See, there's a reason we haven't shipped it yet.
Yeah, someone was yelling ship it in the keynote, and we like to hear things like that. It's a little premature here.
This is the full restart.
This is new kernel starting up again. I have just a few more things I'd like to show you. So anything we missed, Jeffrey?
I think that's it.
Yeah, so far we've found very few apps that don't work in the sparse memory configuration, but I won't be running the ones that don't work for fear of embarrassing those folks here. We don't want to do that. We just want to show you things working well. So I'd like to end this with, well, that works well too. Thank you, Mom. Let's switch to 8-bit mode here. Shall I try it again?
Yeah.
Sure, why not? I'm bold. Well, we'll pretend that worked.
Do it again.
No? Interesting. Well,
moving right along.
You win some, you lose some. I'm not worried.
Works in the labs. Feel free to stop by any time.
Yeah. What should have happened is you should have gotten a border that was yellow around the monitor to show you you're sort of in a yellow window. So, show you one of my pet projects. It's actually not mine. It's something that a few of us are working on here at Apple in our free time. You may have heard of it. It's a little application that'll prove just how wonderfully compatible this really is, because we're going to show you running an entirely different machine. This is Gus. This is... This is a pet project we've worked off and on in our free time for the last 4 years. It's nothing terribly exciting.
An emulator on top of
an
emulator.
entirely different processor and machine being emulated here. But for those of you who remember way back, I think 15 years ago, so, I'm not going to play this game because you don't want to see me play a game, but Choplifter. Anyway, just like to show you that everything works, even things we haven't shipped.
Thanks, Jim. So with that, we'd like to invite a few of our cohorts in crime up here for some Q&A. Just to recap here, the Blue Box provides a very compatible, high-performance, robust, integrated experience. That's our goal. It's our job. We love it. And it's going to provide a number of advantages, including better I/O performance, protection for the yellow box, fast startup, sparse memory, and it's just another hardware platform. But don't touch the hardware directly, please. So we have the Rhapsody hands-on lab downstairs. I understand that the slots are, if they're not completely filled up, they're mostly filled up. But feel free to drop in the second half of every hour, because what happens is people come in, they try their stuff, it works, they leave. And that leaves us with a bunch of open machines. So feel free to stop by. We'll be happy to try to get you on a machine to test your application, your software. We really want to find any problems early, and we're going to do our best to seed this stuff to you as early as possible. Other sessions of interest, the Rhapsody technical overview, and the CoreOS file system's already gone by, but those tapes are available. And the Rhapsody user experience on Thursday. Highly recommend it. You can get all of the scoop from Kurt about the integrated experience. If you have any questions or want more information or whatever, email bluebox@apple.com. We'd love to hear from you. So with that, let's do some Q&A.
Do introductions?
Actually, why don't you introduce them? So, with me here today is Jim Black, you've already met, Mark Gorlinski, the Blue Box runtime team, Mark Sinekin, the manager of the Blue Box team, Jim Murphy, MaxBug aficionado and member of the Blue Box team, and you've already met me. So let's go for questions.
Let's start on this side of the room first.
Hi, Bob Bierman, RIB Computer Consulting. Yesterday at the FileOS Rhapsody session, I asked a question about being able to get long file names from the HFS Plus partition from the Blue Box. They said, no way. You said here, though, that we can use Apple events to communicate between yellow and blue, and also write a device driver for the core kernel and communicate that up into the Blue Box. Can that be a way of actually accessing the true HFS Plus file system from Blue Box?
So the real issue there is the availability of the APIs to access that information. And insofar as the Blue Box has direct access to HFS Plus, it's the same HFS Plus that's in the real Mac OS. So from within Mac OS, within the Blue Box, normal Mac OS APIs aren't going to give you that information. Now, I don't know if the Rhapsody, or if the yellow box APIs are going to get you that access to that same information. If Blue isn't putting that information there, there's not going to be any long file names to get at.
But if you already have long file names on a volume that's being shared,
it depends on the API availability inside the yellow box for getting at that. If you could, then yeah, you could Apple event over to Yellow and tell Yellow to go access that information and then get that information back.
And what about using a device driver for it?
Basically what's going to happen is the Yellow APIs do allow full access to long Unicode names. If you get them through the short macOS APIs, they're going to be mangled down to 31 characters. Based on the question that you asked last time, we're thinking of putting an API in Yellow to let you find out what it would be mangled to. But basically, if you want to take advantage of long Unicode file names, then move to the Yellow box and use the new APIs.
But I'm thinking for those files that are already long that customers want to access, users who want to access them from the Blue box.
Well, those would have to come from Yellow because you can't create those files from Blue.
Right. They may already be created. They may be created from a Unix system. They may be created from the Yellow box.
You'll see the files, but their names will be truncated.
Right. What I'm trying to provide is a system that would allow the users to see the untruncated name.
Okay. I mean, in general, we're trying to be, complete macOS, so we're not extending APIs in the Blue box that you're not going to find in macOS. But we can probably handle that particular issue if you want to.
I mean, what you propose would work just fine if that's what you'd like to do.
Okay, thank you.
Hello, Jim Jarrett from Kodak. I've got an app that uses lots of temporary memory. Given the new memory map that's going to be there with Blue Box, do I have anything to worry about?
Well, there's a couple of things. One, the temporary memory that will be available when sparse memory is turned on is going to be some percentage of real memory in the system. Okay? So that's how that number will be calculated based on some empirical number that we'll play with just to see how it works. You might consider switching over to the new memory system, memory manager that's going to be provided as part of Mac OS, which is the new OpenDoc memory manager, is going to be made available as a system service. That memory manager, when running in sparse, is probably going to be routed to real sparse memory and not come out of TempMem at all. So,
right. Thanks.
Mm-hmm.
Looks like we have a mic problem over here. Let's go ahead and take the question on the far right, and as soon as that's fixed, we'll come back to you.
Need to communicate via TCP/IP between a Blue app and a Yellow app. Is that possible?
So, given two separate IP addresses...
Either way. I mean, they're going to be two separate ports.
Yeah, that should work just fine.
So there's another mechanism for communicating between Yellow and Blue besides Apple events, and that's TCP/IP.
Correct. And there's also the file system, and there's also Apple Share. You'll probably be able to use file sharing between the two systems as well, because there'll be essentially two different machines.
Thanks.
Okay, let's try you again.
Okay, here we go. Jonathan Hoyle, Eastman Kodak. Question and comment. The comment is I'm very impressed with what I've seen with Blue Box so far. It looks like the compatibility is very tight. The weakest area seems to me to be is the integration. I think of the Windows 95 3.1 paradigm where all the cooperative 16-bit 3.1 apps run seamlessly, tightly integrated in 95 as separate apps. You don't have to run Windows inside of a separate window. And I realize the direction is for speed, get the product out the door, but any way to tighten that integration so that you can have Blue apps and Yellow apps on the same Finder would be, I think, more appreciated for the overall experience. And the question I had was the statement made earlier that Yellow Box, or I'm sorry, Rhapsody API calls cannot be access from a Blue application running inside Blue. Yesterday morning there was reference of, presumably it would come as an extension, Yellow Box riding on top of Mac OS. Whether you have yellow on Blue on Rhapsody, or whether you somehow direct those to the real Rhapsody, is there a way around that? Because I would think I would want to write to Rhapsody.
Right. So Yellow Box for Mac OS should work on the Blue Box. Okay? And yeah, it's weird to me too. However, in that mode, Yellow Box apps are not protected.
Right.
Okay? You have the advantage of probably, and this hasn't been decided yet, having access from those Yellow apps, some of the macOS API services, right? Because we believe you're going to have that. But you won't be able to then, if you write an app that way, you're going to want to migrate that towards a full Yellow application that doesn't require those macOS services, or you won't get the protection and the performance boost of switching over to Rhapsody.
Well, if I made the jump all at one time, this wouldn't be an issue.
Yeah, understood.
But I'm thinking that there's going to be that in-between point.
And that will definitely work.
Thank you.
Question in the center?
Testing. Back in business. Alec Carlson from Smith Micro. I have 6 questions. I'll ask 2 and get back in line. One of the problems with the Mac OS since the first day the 128K shipped is serial port arbitration. How is that going to be handled between the Yellow and Blue boxes?
So the Blue box is going to present the same serial port arbitration for the internal visible serial ports, that is, those virtualized SCC channels that Blue has always had.
Well, there are none.
Exactly. However, underneath that SCC implementation calls through to the CoreOS driver. And that CoreOS driver is going to use the arbitration services provided by Yellow Box and the CoreOS.
So if Yellow has the port in use, you'll get port in use as an error back from the serial port open?
Correct.
Got it. Okay. And this may have been asked earlier in another session, but are you going to support multiple Blues?
So this is one of those ongoing, ever-debated topics, multiple Blue boxes. It's non-trivial. The real issue has to do with all the shared resources. And for a bunch of them, we're solving that problem just to do Blue and Yellow integration. But for a bunch of them, we're not. For example, when you're accessing a disk, the desktop database is open all the time. And 2 people can't have the desktop database open all the time, except for shared volumes where the CoreOS has it open and we're just talking to the CoreOS. So the short answer is the first release is definitely not going to support multiple Blue boxes. We may do it in future releases. If we do that, it will be with some caveats and limitations. Certainly it's going to have one of those memory footprints that you'll just love. Answer the question?
Yeah, thanks. I'll let somebody else answer.
We go with this side.
Rich Kozlowski from Skeephole Inc. Real simple one for you. Have you tested soft windows on the Blue Box? Yes.
I did not, and we've just really begun starting to test applications.
Is anybody from Insignia in the audience? Please come to the compatibility lab. We'll take care of that for you.
And I'd like to be there when he does it. Thank you.
Back to the center.
Carl Gustafson from the Computer Vision Center for Vertebrate Brain Mapping. This may have been answered already, but will there be some way to tell if you're running in the Blue box, some gestalt or something? I talked to video capture boards, scientific capture boards, and I can turn that off if I know not to do it.
Yes, there will be. The gestalt's not necessarily finalized yet. And it's just like another hardware platform. So really, you don't want to be checking whether you're on the Blue box. You really want to be checking to see whether your particular device is available.
Right. Okay. Fair enough.
David Otter with Hewlett Packard. What I'm wondering, is there any way to specify that you only have access to particular SCSI device from the blue box and not allow the yellow box to have access to it?
Yes. The configuration UI hasn't been decided on yet. We envision a visual interface that basically lists the available devices, and you could basically pick whether it's for blue, yellow, or both.
All right, thank you.
Mm-hmm. Back on this side of the room, please.
Hi, John Cabot, Iris Associates. For client-server apps, is there any way, apart from the ones you've outlined, for the client to run in the Mac OS in the blue box and communicate with the server running in the yellow box, specifically using, say, shared libraries or something like that?
No, there's no sharing of code between blue and the yellow box. The only way that you can communicate is going to be with Apple events.
Okay.
Or networking, or Apple Share, or TCP/IP, or the file system.
Fair enough. Are you going to improve the performance of Apple events?
We're looking into that for both Mac OS and the Blue Box. Again, we don't make any changes to the Blue Box for just the sake of changing the Blue Box, so we want those kinds of enhancements to go both ways. Certainly the performance of Apple events in yellow should be significantly better than the performance of Apple events inside of blue. So we'll see what we can to reduce the bottleneck, but it's non-trivial.
Okay, and a follow-up to your earlier comment on temporary memory. Can you give a more detailed description of why or what solutions we have for our current apps that use temp memory? I assume you're going to provide gestalts and so forth, but will you have other possibilities?
Temp mem has not gone away. It's still there. It's just that the application heaps don't come out of it. So you still have temp mem.
But you recommend not using it under Blue Box?
No, we don't recommend not using it. It's just that if you want to grow your application, you just change the size of the application size, and you have more space available to your application without using temp mem. But if you want to use temp mem and require it, it's still there.
Thanks.
A question from the center, please.
John Hansen, Microtech Lab. Will there be any way for a Blue Box application, would there be any way to tell that some device is being used by Yellow Box rather than just the user has turned it off?
That's a good question. When we get further down that line, I'll get back to you. We haven't gone down the device sharing path far enough to know what we need to provide in terms of API to understand it, as opposed to the user experiences, oh my God, the port's in use. I expect that we're going to want to do something to enhance that.
A question from the right, please.
Malcolm Tees, Blaze Technology. Can you tell us a little bit about some of the typical problems that applications have when they do not run successfully on Blue Box? I'm looking for things to avoid. That is, aside from the obvious kinds of stuff as directly accessing hardware or directly accessing low memory globals.
So some of the things we've seen are when you're viewing Mac in a window, things that don't do the shield cursor, show cursor correctly, isn't actually drawn on the screen then. So that's one of the big ones. Mostly the problems have been ours, if there are problems at all. With sparse memory turned on, applications that touch memory outside of their heap have a bad tendency to crash. I think that's really it. The only other things that don't work are services that we haven't finished implementing yet, like calling the SCSI manager, but those will work.
Temporary memory is often considered outside of the heap. Is that how does that fall in?
No, that
Yeah, when Jeff says outside of the heap, he means accidentally overwriting past your heap and putting bits of data in the place you didn't allocate. So overwriting the end of the allocated heap. We're not talking don't write outside of your heap when you allocate memory and temp memory. That's, you allocated it, you own it. It's just that there are some bugs that are latent on the real Mac OS that when you move the address space around a little bit, you find them. They may be benign because you're not running an application and that happens to be abutting that heap. So you're writing into empty space in the process manager heap, for instance. When you start to move things around, you find that people used to just work and you've accidentally broken them, but you haven't really changed anything. So,
question here.
My second question got answered already, so now it's just an easy one. When are you going to finish the SCSI manager?
well, that's next on my plate. I did ADV first. We support, for the most part, ADV devices, and I'm moving on one hardware item. We'll be working on that relatively shortly. It'll be there when we release it to you, so soon.
Okay. Question from the center, please.
Larry Barris from Perceptive Scientific Instruments. You keep saying not to directly access hardware. Unfortunately, in our case, we have hardware that's custom made for our application. Has there been any thought given to how we'll access PCI cards and SCSI devices through the blue box or through the yellow box?
Well, SCSI devices will work just fine going through the SCSI manager. In terms of a PCI card, that's where you want to write a CoreOS native driver. That driver will be made visible to you as a normal device manager style driver in the unit table, and you'll be able to communicate with it that way.
Does that driver model, does that support things like time-critical tasks?
Yeah, it will.
Thank you.
Question from the far right, please.
Thane Henninger from iOmega. A couple questions. On the SCSI manager, you said that certain devices will be available either in blue or in yellow unless they're being shared according to the file system. But if I made a SCSI manager call from an application in the blue box to a device that's, say, reserved for yellow, will I just not see it? Or what will it appear to the SCSI manager that you're about to create?
We haven't decided if we're going to spit back an error or not. I suspect that we'll have to. If you're directly targeting an ID number, that's not likely. I think that more likely when you do your scan, you just won't see the devices.
Okay. Secondly, how easy will it be for blue box applications to communicate with drivers? Like, for example, if you have devices, SCSI devices, that are communicating or are used in the yellow box, all right, and then you will have a blue box application that wants to communicate with those devices, but sometimes they may be reserved for yellow and sometimes they may not be. Can you, from a blue box application, communicate with the drivers for that that are in the yellow box?
Yeah. The issue is whether or not we can allow the blue box managers that don't understand anything about the yellow box to have direct access. And that's what we're trying to avoid. So where we're talking to an actual driver, having the blue box communicate to those drivers and have them tell them whether it's okay or not is going to be fine. And we'll have a way, I'm sure, of being able to tell whether a driver is marked for blue, yellow, or both.
Okay, so in other words, from an application standpoint,